All right, welcome to The Explainer. Today we're tackling a classic engineering mystery. You know, the kind of problem that, in an interview, really shows who's a senior engineer and who's still on their way up. This isn't just some textbook example. This is a real playbook for how to handle things when the pressure's on.
So, let's just jump right into the scenario. Picture this, it's 3 in the morning. Your pager screams at you. You check the dashboards and the system isn't totally down, but it's kind of bleeding. Some users are getting errors, but not all of them, and it's totally random. This right here, this ambiguity, is the moment of truth. It's what separates a junior engineer who starts to panic from a senior who knows exactly where to start.
Okay, what you're looking at is a textbook poisoned well problem. You've got one bad server, just one, and it's making the entire fleet look sick. It's like a single drop of poison in a well. And if you don't know how to find that one bad apple, man, you can run in circles for hours. So we're going to put on our detective hats, solve this thing, and show you how to turn this exact case study into an amazing story for your next interview.
All right, first things first. We're setting the scene of the crime. The absolute #1 rule, don't touch anything yet. You got to understand the facts of the case first. A good investigator doesn't jump to conclusions. They start by gathering evidence.
So here's the initial incident report. What do we actually know? We've got these random 500x errors and timeouts popping up. It's hitting a subset of users. Totally scattered, no geographical pattern. Our setup is pretty standard. Load balancer, app tier, database. But here's the kicker, the thing that makes this tricky. There were no recent deployments, no config changes, no big traffic spike. The system just kind of decided to break all by itself. Okay, so now we're following the clues. And let me tell you, how you kick off this investigation is everything. You have to be methodical, you have to think in layers. We're going to start from the outside, the edge of the system, and work our way in. Why? Because it stops you from doing what everyone wants to do, which is jump straight into the code and start chasing ghosts. So, in an interview, this is your moment. You start asking scoping questions, and the answers you get, they're pure gold. Is it all users? Nope, just a subset. Any recent deploys? None. Traffic look weird? Totally flat. See? These answers are huge. They immediately steer you away from thinking it's a bug in the app logic. It's almost certainly an infrastructure problem. And just like that, with a few smart questions, we've basically eliminated 90% of the possible causes. And this is where things get really interesting, because the high-level dashboards, the fleet-wide signals, are totally misleading. You look at them, and everything seems fine. Load balancer health checks? All green. CPU and memory on the app servers? Normal. The database? It's practically bored. The only weird thing is that our P95 latency is up, so the slowest requests are getting even slower. Now, everything is screaming, look at the database. But the database swears it's fine. And right there, that's the trap. But see, looking at the fleet as one big blob, that's the classic mistake. The average, that single aggregate number on your dashboard, it's lying to you. And it's hiding the real culprit right there in plain sight.
So this is it. This is the million-dollar question you ask in the interview. It shows the interviewer that you don't just take the dashboard at face value. You're showing you understand a fundamental truth about big systems. Averages lie. They can be so misleading.
So what do? We stop looking at the average and we start slicing the data. We look at the error rate not for the whole fleet, but for each individual server. And when you do that, bam, the picture just snaps into focus. Almost every server is at 0% errors. But then there's this one guy, app node A, failing on a whopping 30% of its requests. We found it. We found the source of the poison.
This whole thing actually has a name. It's called Simpson's paradox. It's this weird statistical illusion where you have a really obvious trend in a small group, but when you mix it in with the big group, the trend just vanishes, or even reverses. Our one bad server, app node A, that was our small group with a very clear trend, tons of arrows. But its screaming was completely drowned out by the silence of all the healthy servers. But not anymore. We found our culprit.
Okay, we found the bad guy. Now, the instinct for a lot of engineers, especially more junior ones, is to dive right in and figure out why it's broken. But that's not what a senior does. The #1 priority is always the user.
A senior engineer thinks in 2 phases. Phase 1, containment. You immediately yank that bad node out of the load balancer. No more traffic goes to it, period. And just like that, the bleeding stops. The global error rate plummets back to 0. Then, and only then, when the users are safe and the system is stable, do you move on to Phase 2, diagnosis. You can now take your time with the isolated machine. This is huge. It shows you protect the user experience first, no matter what.
All right, so now we've got the server isolated, and we can finally do our deep dive. Pretty quickly, we see it's having trouble talking to the database. It's dropping packets all over the place. So we run some basic network diagnostic tools, DMessage and ethtool, and there it is, the smoking gun. The network card itself is screaming about transmit and receive errors. So it was never the application code, it was never the database, it was a faulty piece of hardware on one server, probably some buggy firmware, that was causing all this chaos.
But we're not done. And this, right here, is maybe the most important part of the story. A junior engineer fixes the broken server. A senior engineer fixes the system so that this kind of problem can never, ever happen again.
This is the part of your answer that makes interviewers lean in. They want to know, what did you learn? So you say, well, first, we added alerts for per-instance error rates, not just fleet averages. Then, we built automation to automatically kick a bad node out of the load balancer. And we made the code more resilient with circuit breakers. And finally, we put a policy in place to keep all our hardware firmware up to date. You see what you just did? You took one single server failure and turned it into permanent, long-lasting improvements for the entire platform.
So let's wrap this up. Knowing how to solve the problem is one thing, but knowing how to tell the story in an interview in a way that just screams senior engineer, that's the real magic.
This right here really just lays it all out. The difference in mindset is everything. Look, anybody can just list off the technical steps they took, but a senior engineer, they tell a compelling story. They show how they sliced the data instead of just looking at averages, how they used a methodical process instead of just jumping to blame the code, how they didn't just fix the one broken thing, they built guardrails to protect the whole system. It's a story about impact, about learning, and about creating lasting value. So when you're in that interview, telling your own stories, make sure you hit these key points. Talk about how you started with scoping questions, not just wild guesses. Explain your systematic, layer-by-layer troubleshooting. Make a big deal about how you mitigated the user impact first before you went hunting for the root cause. And of course, end with how you built long-term resilience. Explaining the why behind everything you did, that's the recipe for showing senior-level thinking.
And this is really the philosophy you want to live by. Remember this, an incident is a terrible thing to waste. It's basically the system giving you a free, if painful, lesson on how to make it stronger. If you can frame your stories and your work around this idea, you're always going to stand out from the crowd. And that's it for this explainer. So I'll leave you with this question to think about. The next time you run into one of those weird, confusing, intermittent bugs, don't just fix it and move on. See it for what it is, an opportunity. It's your chance to turn a problem into a fantastic story about how you put on your detective hat and made the entire system smarter and more resilient. Because that is the story that gets you the job.